Hi guys, just wanted to say hello and apologize that this video did not get posted sooner. I meant to have it done by about lunchtime, so apologize for being a little late on that. What we're going to talk about this week are sequences, arithmetic and geometric sequences. Okay, sequences are just patterns. If we have a sequence, arithmetic or geometric, these are patterns, and we are going to determine if something is an arithmetic or geometric sequence. And I know those sound kind of complicated, but once you see what they look like, hopefully you'll realize they're really not too crazy difficult. An arithmetic sequence is the first one we're going to talk about. If it is arithmetic, it means we are going to add or subtract the same number every time. Okay. So if it is arithmetic, our pattern is that we are either adding or subtracting the same number every time. Okay. So we're going to start down here. Example 1 and example 2, you can read through those on your own time if you like. But I'm just going to jump in and start with problem number 1 under the exercises. Okay. Directions for 1 through 3 say, determine whether each sequence is an arithmetic sequence. Write yes or no, and then explain. Okay. So the way we're going to figure out if these are arithmetic is we're going to look at whether or not we can get from one number to the next by adding the same number every time. Okay. So here's what I mean by that. I want to go from 1 to 5. Okay. So I want to know what's the difference there. How much did I have to add to get from 1 to 5? So if I just do 5 minus 1, that gives me 4. So I know this was a plus 4. 1 plus 4 is 5. Okay, now let's see what the difference was from 5 to 9. Well, 9 minus 5 is also 4. Okay, so you can see that that has the same jump there, plus 4. If I want to check the rest of the sequence, plus 4, 9 plus 4 is 13, plus 4 is 17, and so on. Okay, so this is a yes. This is an arithmetic sequence because it has a common difference of 4. Okay, I'm just going to add 4 every time and continue with that pattern. So that tells me that this sequence is arithmetic. Okay, so let's look at number 2. Determine if this is an arithmetic sequence. So I want to figure out now, what do I have to do to get from 8 to 4? Well, I can see that I'm getting smaller as I go, right? So I want to know, what do I have to subtract? Okay, so if I start with 8, I can subtract 4 to get 4. Okay, so let's try going that again. 4 minus 4 is 0. 0 minus 4 is negative 4, and so on. So yes, this is also an arithmetic sequence because it has a common difference. It has a common difference of negative 4. To get to the next number every time, I'm just going to subtract 4. Now, if we look at number 3, let's see if we can find a common sum or difference. Okay, or a common difference. Are we going to add the same number or subtract the same number to go from one number to the next? Okay, so I can tell that I'm going to be adding something because I'm increasing, getting bigger. 1 plus 3, I'm going from 1 to 3, so I have to ask myself, what would I add to get to 3? So I can add 2. 1 plus 2 is 3. Okay. But then I look here, and if I do 3 plus 2, well, that would only give me 5. Okay, to get from 3 to 9, I would have to add 6. Okay, so this is not going to be arithmetic because we can't add or subtract the same number over and over and over. There is no common difference. Okay, so 1 and 2 are arithmetic, 3 is not. Okay, because it's only an arithmetic sequence if you get to the next number by adding that common difference, adding the same thing or subtracting the same thing every time. Okay. All right, 4, 5, and 6 Still deal with arithmetic sequences, but it's a different type of question. Instead of asking us yes or no, is this arithmetic, it says find the next 3 terms of each sequence. Okay, so basically for number 4, I have 1, 2, 3, 4, 5 terms. It wants to know what would the next term and the next term and the next term be. So in order to figure that out, we need to look for our pattern. We need to figure out what our common difference is in the arithmetic sequence. So I want to know what would I have to add to get from 9 to 13. Okay, so if I'm at 9, 10, 11, 12, 13, so I'm going to add 4. Okay, 13 plus 4 is 17, plus 4 is 21, plus 4 is 25. So the way I figure out my next 3 terms is I'm going to just keep adding 4. 25 plus 4 is 29. 29 plus 4 is 33. 33 plus 4 is 37. So 29, 33, and 37 are the next 3 numbers in that sequence. Okay. We're going to do the same thing for number 5. Okay, we're going to find that pattern, find our common difference, and then use that to figure out what the next 3 numbers in the sequence would be. Okay. So now this sequence is decreasing. So instead of adding 4 or adding a number, we would be subtracting. So I have to say, okay, what would I have to subtract here to go from 4 to 0? Okay, well 0, 1, 2, 3, 4. So it has a difference of 4 there. So I'm going to subtract 4. And I can see that that pattern follows throughout the sequence. Minus 4, minus 4, minus 4. Okay. So to find my next 3 numbers, I'm just going to keep subtracting 4. Negative 12 minus 4 is negative 16. Minus 4 is negative 20. Minus 4 is negative 24. Okay. So the next 3 terms of our arithmetic sequence would be negative 16, negative 20, negative 24. Okay. Now, if you're working through this video at home, if you have printed this worksheet off or have written this down, I would pause right here and try number 6 on your own real quick. So pause the video, try this one on your own, and then hit play again, and that way you can kind of check and see if we are on the same page or if we get the same answer. So I'm looking for my common difference. To get from one number to the next, like 29 to 35, I need to add 6. 35 plus 6 is 41, plus 6 is 47. So to find the next 3 numbers in the sequence, I'm just going to keep adding 6. We got 53, 59, and 65. Okay. All right, so there's one more thing I want to talk about before I stop this video, and I'll talk about geometric sequences in the next video. But what I want to talk about first is sometimes you're going to be asked to write an equation for the nth term of an arithmetic sequence. Now, this phrase nth term, that's always seemed kind of strange to me because we don't know what n is. But that's what that means. It means if I wanted to find a particular number in the sequence, let's say I want to find here, they gave us 5 numbers, and I wanted the 6th, 7th, and 8th term. Well, what if I needed to know the 38th term or the 142nd term? I don't want to have to just keep listing all the items in the sequence until I get to the number I need. That would take me all day. So what we're going to do is we're going to write a rule or an equation for the sequence that we could use to find whatever number we needed in the sequence. Okay, so I'm going to go ahead and let you ignore where it says then graph the first 5 terms of the sequence. We don't have to graph. I just want you to write the rule for these sequences. Okay, so it's going to start out the same way we started with problems 1 and 2, and then 4, 5, and 6. We're going to look for that common difference. Okay, what am I increasing by? What am I adding or subtracting every time? So if you look at number 7, let me zoom in a little bit here. If you look at number 7, we go from 1 to 3 to 5 to 7. So for this arithmetic sequence, the rule is that we're going to add 2, add 2, add 2. So I could continue adding 2 every time. Okay? So what we're going to do is, the way we're going to write that rule is we're going to say a to the n is equal to that common difference. You know what? Hold on. I'm going to have to go back and stop that video. Let me get myself straight. I haven't done arithmetic sequences in a while. So I'm going to go back and